Welcome friends, I am Ramesh Rana, a teacher teaching mathematics for the last 41 years. Now I am here to guide parents to enable them to help their visually impaired children in learning mathematics through Taylor Frame. Just by learning this simple tactile system, you can teach whole of school level arithmetic and algebra as much as you know to your visually impaired child. I welcome you to my class once again for the good cause. Welcome friends. In this class, performing multiplication of numbers on Taylor frame will be discussed. All types of numbers will be covered. Please like and subscribe the channel. Multiplication of two integers. Write the first integer. Now in the line below it, write the multiplication sign and write the second integer. Leave a line space and write the product. For example, 349 into 6 is equal to 698. Let us now come to Taylor frame. You should know the multiplication sign. It is two dots right up. Now write 3, 4, 9. Come to the second row, write multiplication sign and then write 6. And leave a row, blank row and multiply. The product is 698. Again note that here also instead of this line we have left a line space as was in addition, as was in subtraction. So it's almost same. Now you can easily form the concept that whenever we have to find the resultant of addition, of subtraction or of multiplication, instead of line we leave a line space. Multiplication of large integers. If numbers are large, multiply in steps and add. That's what we do. For example, 349 into 62, we first multiply by 2, then we multiply it by 6 and leave units place blank. Then we add the numbers. It is 21638. Same way, first revise multiplication sign is two dots up and then write 3, 4 and 9. Look at the orientations. 9 orientation is very special. 9 and after that will be 0. Okay, 9 orientation. Then into 6 and 2. Same way we will leave a line space instead of drawing a line and multiply first by 2. On multiplying first by 2 we get 698. Then we will multiply by 6 and on multiplying by 6 we get 2094 and a space is left empty. We are adding, as we are adding we have to put a line, therefore we will leave a line space and add. So this is 2 1 6 3 and 8. Okay, if you try to understand the concept, it is the same. Multiplication of decimal numbers. First write the first number in a row with decimal at proper place. Write the second number in the row below it and multiply. For example, 34.9 into 6.2 is solved as 34.9 into 6.2 multiplied by 2. This is 698. Then multiply by 6. It is 2094. Then add the numbers. It is 216.98. Why 0.98? Because decimal should be after two places, one from zero point 0.9 and one from zero point 0.2. These are two places. Now, I am going to represent it on Taylor frame. Symbol for Taylor frame for decimal is this. Now let us go ahead. This is write 34, 34, then decimal symbol, and then 9. In the second row, put a multiplication sign, then 6, then decimal, then 2. After this, you write 6, 9, 8. Look, I have left a space in between because the line was there. For line, leave a space. Now multiply by 6. This is 2, 0, 9, 4. Because it is by the second number, so leave one space empty at the end. We generally put a cross when we do it on paper, otherwise. Now add, because we are adding, a line is left, so we get 216 decimal sign, 0.9 and 8. Okay. Multiplication of proper fractions. Write both fractions in the same set of rows with a multiplication sign in between, leaving no space on any side of the negative sign. Cancel if a number is common in the numerator and denominator. Multiply numerator of first by the numerator of second and denominator of first by the denominator of second. For example, 4 upon 15 into 3 upon 5 is first written as 4 upon 5 into 1 upon 5. Why? Because between 3 and 15, 3 of the numerator of the second and 15 of the denominator of the first, 3 was common. So we should cancel by 3. Otherwise, the calculations become complicated and numbers become large. Then this becomes 4 upon 25. Now on the Taylor frame, you can represent 4 upon 15 into sign of multiplication 3 upon 5. This is equal to, note the equal to sign also, 4 upon 5 into 1 upon 5 is further equal to 4 upon 25. Look, I always give the two calculations side by side so that you may compare and form a clear concept. In fact, there is not much difference between doing calculations on paper and doing it on Taylor frame. The parents have already done on paper, so they can compare and form a clear concept, then it becomes easy. Multiplication of mixed fractions. For multiplication of mixed fractions, change them to proper fractions, and follow the same procedure as in proper fractions. For example, 2 4 upon 15 into 3 1 upon 5 is equal to 34 upon 15 into 18 upon 5 is equal to 34 upon 5 into 6 upon 5, because 3 was common between 15 and 18. So 15 when cancelled by 3 is 5 and 18 when cancelled by 3 is 6. So we get 34 upon 5 into 6 upon 5. Multiply numerator by numerator, that is 204, and denominator by denominator, that is 25. Now the main thing is, if numerator is greater than denominator, it must be changed to mixed fractions. So on changing it to mixed fractions, we get 8 4 upon 25. Let us see on Taylor frame now. To leave a space 4 upon 15, because 2 is the integer, therefore a space is left to represent mixed fractions. Same for the next, into 3, leave a space, then write 3 upon 5, which is equal to 34 upon 15 into 18 upon 5. Further, it is equal to 34 upon 5 into 6 upon 5, which is equal to 204 upon 25, equal to 8 4 upon 5, 4 upon 25. See, only different thing was how to present a mixed fraction. This we have already discussed while representing numbers on Taylor frame. Write the integer, leave space, and then write the fraction. Also note that there is no line space when we write a fraction. Okay. Thanks for watching.